in this question, a train S1 is moving towards the train S2, which is at rest, and from the another side, the observer O is moving towards the train S2. Now their speeds are given. This is 30 meter per second. This is moving with 10 meter per second. And now what is said that how many number of bits which the observer will hear when it will be at a distance of 600 from S2, and S2 and S1 distance will be 800. So naturally this distance will turn out to be 1000 because it's a Pythagoras triplet. So 6, 8, 10. Now we'll first find that how many bits this observer will hear because of the source S2. Now for that, the apparent frequency, so I will say n because of this S2 is going to be, here it is v plus velocity of observer, that is 10, upon velocity v, because this is not moving, source is at rest, into the frequency which it is giving, it is 120 hertz. So naturally this answer will turn out to be 340 upon 330 into 120, which is nothing but 34 by 33 into 120. So this is the frequency heard by the observer due to the source S2. Now similarly we can find out the frequency heard by the observer due to the source S1. For that, what I will do is to take the components of their velocities in the direction such that this is going to be 10 cos theta and its velocity is in this direction, so its component will be 30 sin theta. Now due to that, what will happen to its frequency which will be heard by the which will be heard by the observer due to S1, it is going to be v plus. Now velocity of observer is 6 and this is v minus, and the velocity of source is 24 into 120. If you solve this, it is going to become 330 plus this, so it is 336, and this is 330 minus 24, so it is 306 into 120. So 6 is a common factor, so this is 51, and this is going to become 6, 5 and then 6, 6. So 56 by 51 into 120. Now how many bits will be heard? So for finding the bits, you will just have to subtract these two. So the number of bits are going to be, so it will be 56 by 51 and 33 by 34. So 56 by 51 into 120 minus 34 by 33 into 120. So 120 will be taken out. So this is 56 by 51 minus 34 by 33, and if you solve this, this answer turns out to be 8.128. In this question, it is said that the instrument is made up of 4 different metal strings, and their mass per unit length for string 1 is mu, for string 2 is 2 mu, for string 3 is 3 mu, and for string 4 is 4 mu. Then there are 2 questions based on this information, and also it is said that the fundamental frequency f naught is 1 by 2l naught root t naught by mu naught. Secondly, you cannot have your length going beyond this length, that is L0 and 2L0. So it must lie in between L0 and 2L0. Now what is asked in the first question is, if the tension in the each string is T naught, then the highest fundamental frequency in multiple of F naught. Now we know that the F naught is, I have already written here, so F naught is 1 by 2L naught root T naught by mu naught. Now similarly, if I go for the string 2, then F2 will be how much? It is going to be 1 by, and that length is same. Now why it is same, I will discuss, and this is 2 mu naught. Why it is so for the string 2? Because it is asked that highest fundamental frequency. Now for getting the highest fundamental frequency, my length should be minimum, and hence I will have to take it as L naught only, even though it can vary from L naught to 2L naught. That's why this highest word is important. And now the question remains straightforward. So 1 by 2L naught root T naught by mu naught, so obviously it is going to be F naught by root 2. Similarly, if you go for third, then it is 1 by 2L naught root T naught by 3 mu naught. So it will be F naught by root 3. Similarly, if you go for F4, it will be F naught by root 4, which is F naught by 2. So naturally, for this, it is going to be P. for this it is going to be R, for this it is going to be S, and for this it is going to be Q. So it is P, R, S, Q. So answer option for this question will be A. In this question, for these 4 different string, what they did, they have changed the length L0, 3L0 by 2, 5L0 by 4 and 7L0 by 4. And they have also said that they are having their first harmonic, third harmonic, fifth harmonic and 14th harmonic. But the another important information which is given is that they all have the same frequency, which is that of the fundamental frequency F0 1 by 2L0 root T0 by mu 0. Now what we have to find is we have to find the tension in each string in multiple of T0. So this is a very simple and straightforward question, because it is given that F0 is 1 by 2L0 root over of T0 by mu 0, and I can equate that with all the other frequencies for these 4 strings because their frequencies are same. So for the first string it is 1 by 2L0 and this is going to be root over of T1 by mu 0. Similarly, for the next string, it is having a third harmonic, so it will be 3 by 2 times its length. It is going to be 3L0 by 2, and this is root over of T2 by 2 mu 0 because its mass per unit length is 2 mu 0. Then I can equate this with the fifth harmonic of the third string, so 5 upon, this is going to be 2 times 5L0 by 4 into root over of T3 by 3 mu 0. In the similar manner, I can go for the 14th harmonic, so 14 upon 2 into, this is going to be 7N0 by 4, and then this is going to be T4 upon root over of 4 mu 0. So these are the simple calculation. So here I can clearly see that this 1 by 2L0 mu 0 gets cancelled out, so T1 equal to T0, and in the similar manner you can equate this to, you can get T2, T3, T4, and if you do that, you'll get the first option as the correct answer options.